In this lesson, I'll show you how to calculate the volumes of gas collected over water. This is question number 2. The question reads, a common way to make hydrogen gas in the laboratory is to place a metal such as zinc in hydrochloric acid. The hydrochloric acid reacts with the metal to produce hydrogen gas, which is then collected over water. Suppose a student carries out this reaction and collects a total of 154.4 milliliters of gas at a pressure of 742 millimeters of mercury and a temperature of 25 degrees Celsius. What mass of hydrogen gas in milligrams does the student collect? Just like before, let's start by writing out everything we know. We've been told that after this reaction has occurred, 154.4 milliliters of gas is collected. So the total volume is 154.4 milliliters. To change this into liters, you divide by 1,000, giving you 0.1544. This is in liters. And this is happening at a pressure shown right there. That's the total pressure. 742 mmHg. The temperature is 25 degrees Celsius. That will need to be changed into Kelvin for one of our calculations. Take a look at this illustration. We have hydrogen plus water vapor collected. So, according to Dalton's law, the total pressure is equal to the partial pressure of each of the gases. So what I can do is use this formula along with information provided in this chart. This chart gives you information about pressure of water, and at 25, the pressure of water, 25 degrees, is 23.78. So let me write that down. The pressure of water at 25 degrees is equal to 23.78. So according to Dalton's law, we have 742 is equal to, that's the total pressure, the partial pressure of water, 23.78, plus the partial pressure of hydrogen gas. Rearranging, we get 742 minus 23.78. Using our calculator, 742 minus 23.78, and we get 718.22 millimeters of mercury. The last significant figure here is this 8. Everything after this 8 is insignificant, although I'll keep this part just to prevent any rounding errors. Now, to use the ideal gas law to find out what N is equal to, because we can use N and the molar mass of hydrogen gas eventually to find the mass, I need to convert this number into atmosphere. And I can do that by using the conversion factor. 718.22 times 1 atmosphere over 760 millimeters of mercury. This unit and the unit here would cancel out, leaving you with only atmosphere. Using my calculator, the number that I have on my screen divided by 760 gives me 0.945. 0.945, where this number right here is the last remaining significant figure. I can finally substitute this value into the ideal gas law, which is PV is equal to nRT. We want to solve for N, so I'll divide both sides by RT. This cancels these ones out. My pressure is right there. 0.945 times the volume, and that was provided as 0.1544. 0.1544 divided by R, which is the gas constant, 0.082057, and this is being multiplied to a temperature of 25 degrees, which is equal to 298.15 Kelvin. Let's find out what the number of moles are. 0.945 times 0.1544, that's the top part, divided by the bottom, which is 0.082057 times 298.15, and this gives us 5.963 times 10 to the power of negative 3. Now, to go from moles to mass, we'll have to use the molar mass of hydrogen gas, and it's shown right there. Remember, one hydrogen atom is approximately 1.01 grams per mole. Multiplying that by 2, since hydrogen gas is H2, gives us the following. So if I multiply the number that I have on my calculator right now to 2.02, this gives me 0.0120. That right there is in grams. I need it in milligrams according to the question. You see right there? So I'll multiply this number by 1000, and that gives me 12.04. The mass is 12.04 milligrams. And we need this to 3 significant figures. So everything after this 0 is insignificant. The final answer is 12.0. And so there you have it. That is how to calculate volumes of gases collected over water.